Good afternoon, everybody. My name is Mathur. I'm the Global Head of Engagement at the Telecom Infra project. Thank you for joining this breakout session on non-terrestrial connectivity. We have an illustrious set of panelists, in fact, who are going to talk a little bit about the actual space, the confluence between terrestrial and satellite, and what more can happen in that space, and what has been happening already. And from that, we'll probably kick off with just some brief introductions, then go through into just explaining what's happening in the TIP community group that has already been set up, where we have Jerome as a co-chair. Each of our panelists will give a presentation and talk a little bit about their perspectives, and then we'll finish off with a few panel questions. So about an hour or so is what we're looking at. Okay, let's just start with some introductions. Let me go to Natalia first.
Thank you very much. Good afternoon, everyone. My name is Natalia Vicente, and I'm the VP of Public Affairs at GSOA, the Global Satellite Operators Association. So we are an international organization, and I will be able to let you know a little bit later, but this is my first introduction of who I am.
So I'm Jerome Soumagne. I'm co-chair of NTCS, working at Viasat now, and I'm the VP of Systems Engineering, promoting 5G, 3GPP, and TIP-related efforts within our organization.
Hi, everyone. My name is Rajat Kapoor. I'm the VP and Head of Software Frameworks at Capgemini.
Hi, everyone. Ashesh Mishra. I'm the Head of Client Solutions at Aalyria.
Fantastic. Thank you much for the introductions. Jerome, would you actually start off by explaining a little bit more about the non-terrestrial connectivity group, please?
Yes, so NTCS, Non-Terrestrial Connectivity Solutions, as it was said, it was created several years ago, but 2 years ago we decided to change the chairmanships. We moved from MNOs to satellite operators. So Viasat, at that time it was Inmarsat, is co-chairing along SES. And the whole idea was basically to look at improving the integration between terrestrial networks and non-terrestrial networks to help with the integration of those two worlds. And in parallel to the efforts that were ongoing at 3GPP, that was the main mission objective of NTCS. We have delivered a number of requirements and specifications which are available on the website. We have not really obtained the level of traction and interest within the community. And I will explain why it's not time to give up. It's really time to reinforce the message that it's time to really roll up our sleeves and work towards an open ecosystem, because as you know, NTN is very buzzed nowadays, direct to device. There is a lot of things happening, and I'm going to say why you should and we should be more active over the next 2 years on that.
That's fantastic. Thanks for that quick intro, and more to come, I suppose, Jerome. Let's start with a few presentations. So I'm going to ask Natalia to come up and take the podium and talk a little bit more about GSOA and what they're up to.
Well, thank you very much. Let's see if we can have the slides on, or if it's just me who passes it.
Just roll it forward.
Perfect. So, well, I already introduced myself, so I'm Natalia Vicente and I'm working with GSOA. I think it's important to give you a little bit, if you're not very familiar with who we are as an association. We represent 70 companies that are satellite operators, GEO, MEO, or LEO, but also manufacturers, launchers, and ground segment. So in reality, what we are is a platform for collaboration in between all these members, but also a unique voice for the industry when it comes to policymakers, whether it is in a more regional environment or in an international and global environment. And I think our membership represents very much the richness of the satellite industry nowadays. And it gives us the possibility of seeing the market evolution and how and where are we going forward. And so I just want to start by giving a little bit of the remarks of where do we stand as the satellite industry right now, and where do we think that we're going inside this telecom ecosystem that we are navigating now. So let's start by saying that during the last 2 decades, indeed, we have seen tremendous progress on connecting the people. However, we believe that in many occasions, connectivity has been given for granted. But it took a pandemic to actually realize what the necessity of connectivity everywhere and for everyone is to really impact the benefits of the countries, the growth, and the economic benefits, whether it is like for education, for healthcare, for financial matters, but also for working, just like that. So I think those years of pandemic brought us to have a little bit of a mindset change on realizing what is the real impact of connectivity for everyone, everywhere. So even if we have realized all that, there's still 2.6 billion people that is unconnected. Whether it is because of access or affordability or different matters, but we still need to work on bridging that digital divide. And I think that's where all this discussion of the different technologies plays quite a big role in how are we going to make the things, or how are we going to do the things going forward. So there was a study that was published, and you can see some of the data in this slide. There was a study published by LS Telecom and VVA earlier this year, in which it estimates that by 2030 there will be 500 million people connected via satellite. And this will reflect on the benefit of 250 billion US dollars. And this is data that we are seeing more and more the impact that satellite is bringing, whether directly or indirectly, to society. So as we know, the satellite industry is going through a phase of unprecedented growth and innovation. And this is the result of a multitude of new satellite services being launched in the different orbital altitudes, providing more affordable, efficient, reliable, and secure connectivity, including, but not limited, to the most difficult to reach locations, unserved or underserved areas, what is helping bridging this digital divide, but especially bringing meaningful connectivity to everyone. Today, GSOA's members are innovating in space and in the ground segment, enabling much higher throughput speeds and leveraging the unique advantages of satellites. And we do believe, as an association and with the members that we work with, that the future of connectivity needs to incorporate satellite in the equation. And this was a milestone, an important milestone was to include the first technical specification of non-terrestrial networks. So indeed, if I may, before 5G, we used to talk about satellite interworking with terrestrial networks. With 5G and 5G Advanced, we talk about the integration of technologies, adding satellite to a 5G component. And when we talk about 6G, we need to think, and we should work in defining from the start based on different technologies, not just thinking about the technologies as add-ons. GSOA has a specific working group that works in standards. We are very involved with 3GPP. We've worked with NGMN. We think that the initiatives that we are seeing and the projects that we are seeing are bringing us forward. And I think it's the work of the industry together that has made progress. We have seen it with Release 17 a few years back. We are working now in Release 18. And it's I like what Jerome said before, NTN is a buzz moment. We need to take advantage, but it's also important to acknowledge that more than a buzzword is the jointly effort from years that is now getting into a moment that we are ready to develop and we are ready to take hands-on and see what can happen. So indeed, and because I am who I am and I represent who I represent, and in a WRC year, I cannot go without saying something about spectrum. But if we go, what needs to happen next? What needs to happen next from regulators' side for NTN to be integrated in their policies and for satellite to become part of the holistic network? We need that policymakers consider satellite since the beginning, so there is a future where satellite can be part of the software-defined, multi-layer, multi-orbit, a network of networks. In particular, as I was saying this year in WRC, it is important to ensure that we have a balance between the rapid evolution that we are having as an industry, but also having a regulatory framework that guarantees access to essential spectrum for all satellite players. in a way that is non-discriminatory and that provides an efficient policy environment in which multiple telecom players and different satellite systems can operate. So just concluding a bit, and like that we can have a more dynamic conversation, but I think we find ourselves in a moment of innovation and opportunity. I know that in some other forums they like to call a rebirth of the satellite industry. Satellites are clearly an important and a key provision for broadband communication, for rural areas, for places that are more inaccessible, but also it gives us dream and options for the future that we can have when it comes to connectivity. So any restriction to the expansion and innovation of the satellite market will hinder the ability to offer affordable services to consumers and exacerbate the digital divide. So the optimum solution, and we will hear more now, but the optimum solution for connectivity clearly does not rely in one technology. I'm not here to say that we have all the answers. The opposite. I think we are in a moment of collaboration, and we are in a moment of trying new things, pulling the strengths of the different technologies to make solutions more cost efficiently, while simultaneously delivering exceptional resilience and greater availability for a much larger number of citizens. And I'm very happy to be here for the first time because this is my hometown. So it's incredibly an honor for me to be here and also listening from other experts, part of my membership too, and being with such a great audience. And with this, I conclude my opening remarks. Thank you.
Thank you, Natalia. Jerome.
Thank you. Okay, so we are a satellite operator, and I will give you perspectives both from a Viasat standpoint, my company, but also as a co-chair of NTCS, obviously. So just a few words. I don't want to make that too long, but we are present as a combined company across L-band, S-band, K-band, and we are serving not only the narrowband customers, IoT or narrowband in general, but also we have a lot of customers in broadband, whether it's aviation, maritime, government. We have plenty of applications. We have 19 satellites, 11 satellites remain to be launched. We are mainly present in the GEO domain, 36,000 kilometers away from us. We have plenty of customers. We are really a large company as a combined company, 4 billion revenues in terms of annual turnover, 8,000 people. And yeah, I think we are quite dominant along with the newcomers like Starlink, of course. NTN is a reality today. You may have heard a couple of months ago at Mobile World Congress that some people demonstrated sending messages to handsets using GEO satellites. And in fact, that was made possible with the efforts of 3GPP in release 17, but also with the strong support of chipset makers. It's not a secret, we made demos with MediaTek 3 years ago to demonstrate NB-IoT over satellite, and Qualcomm is also very much on board. So anything which really requires scale around, and it's mainly sub-6 gigahertz, L-band or S-band, anything that requires scale where we can benefit from those ecosystems of devices is a great thing for satellite. So yeah, it's happening, it's quick. NTN is being adopted, as Natalia said, very quickly. Very quickly. It's amazing, in fact. I think that's the technology that has been adopted the quickest between its official publication in a standard and actual applications. As Viasat, our objectives are quite simple. I would like to split FR1, which is sub-6 gig, from FR2, because those are really two different use cases. But for FR1, our objective is to make sure that any activity in 3GPP allows our satellites, but also satellites from our colleagues in GSOA, to be interoperable with 3GPP. So we are quite active in standardization, and that's really the number one goal, making sure that the standard doesn't prevent use from the satellite, use of the satellite assets. We also want to develop use case around personal devices, but also professional IoT. The case of delivering a broadband experience to a handset from a satellite remains to be seen, but messaging, yes, voice, maybe, and certainly professional IoT applications in the automotive domain or in such industrial domain is certainly an opportunity for the satellite ecosystem. And what we want is the O-RAN community, the core network community, not to lag behind. It's happening today. All the chipset makers are on board. The 3GPP standard is there, but still we are a bit struggling by making sure that there is an ecosystem of O-RAN providers or RIC application providers or even core network providers embracing the NTN specificities. FR2 is a bit different. It's a bit more in the future. For FR2, we have a lot of proprietary RANs, if you want. I'm going to give a couple of names, Gilat, iDirect. All those radio access networks are proprietary. They are based on DVB usually. And, but it's not a reason. In 3GPP, there is something called non-3GPP access. And we want to certify to badge solutions, whether they are RAN or core network side. We want to badge solutions around trusted or untrusted non-3GPP access. That's one of the goals of this NTCS group. And the last thing is really, making sure that whatever is done as part of release 1819 for the native 3GPP access to be efficient so that it can be adopted by the satellite community going forward. But it's a question of a couple of years because proprietary systems will be used for quite some time still. So I'm just repeating what I said. It's really here, through those use cases, making sure we can badge and BIoT NTN solutions. We can badge, certify core network solution that can cope with the satellite proprietary access. And that's really our goal here. And we'll have someone from Ashesh from Aalyria who will be the first solution provider to be badged in the next coming months. And we welcome more of those companies to grow that ecosystem. We did a lot of work. Frankly, it has not been, from my perspective, a great success, but it's not time to give up. It's really time to work more because it's even more relevant now. Maybe we started that group too early. So now it's time to work all together. We have a lot of requirements that you can access on the website, but in the next few months, we'll badge a solution from Aalyria that Ashesh will present. And Rajat, we also welcome you to work with us on that, to make sure we certify your solutions. So it's prime time now. It's time to join. It's time to contribute. So with this, thank you.
That's fine. Thank you. Thank you, Jerome. Rajat, yourself.
So something about myself, I started my journey decades back, part of Fyuz Software Systems, part of HNS. So I started my journey with the satellite company. I moved to the 3GPP ship, moving to 3G, 4G, 5G. I've seen all the evolution. And it's good to actually see now 3GPP coming back into the satellite communication space. So very excited about this. I think it's a lot of work has been, it's being done by 3GPP now to actually bring satellite communication as part of the specifications. But obviously, well, both the satellite providers and the telco providers have to work together, along with chipset manufacturers, to actually see how all of this comes together. So, well, I'll divide my presentation in two pieces. One about Capgemini, the company I work with, and then, well, how do we see O-RAN? Because well, since morning I've been hearing about O-RAN, how O-RAN can be a technology to actually depend upon when we talk about NTN. So I'll be talking about both these topics. So Capgemini, I think most of you know, is a large services company. We're a $21 billion plus company out there, focusing on IT services as well as engineering services. 3 years back, Capgemini acquired Altran Saracent, through which it got the engineering services arm, and Capgemini Engineering was formed. Now, well, what you would not know, or maybe most of you would not know, is that through that acquisition, Capgemini also has a large portfolio of our own software assets. Now, our intent is not to become a product company. We will never become a product company, but the intent is to help the product companies out there build solutions in a much faster manner, in a cost-economical fashion. Now, these companies can be equipment providers, can be service providers, can be satellite providers. So that's what we are doing as of now. So with this large portfolio of software assets, if you see one of the pillars is the wireless domain, where we have assets in the 5G RAN, 5G core, RIC, SMO, XApps, RApps. So we have been one of the founding members of ORAN, founding members of TIP. So we have been participating in all these plugfests, in all the labs that you would find. We also run labs, actually, also as part of the complete ecosystem. So these are the various industry which we actually enable through our software frameworks. Well, noticeably, you will see that while we work with the comm space, which is both the equipment providers and the service providers, we also equally work with the SATCOM players now. So while I would say in the SATCOM space, or HAPS space, I would say, while we have been also instrumental in actually enabling the world's first commercial HAPS platform, which the world has seen, we have also been working with a lot of SATCOM providers now in the NTN space and helping them both on the ground station as well as satellite payload space as well. So while we are doing all of this, we also will have achieved a lot of accolades also with our 5G software. We have been awarded the NASCOM Award, the Global Awards, the 5G Challenge Award, which we got 2 weeks back. We have also been operating a lot of labs. The I-14Y lab have been part of the Digital Catapult lab as well. We also run our own labs, global labs which we have across Paris, San Francisco, Mumbai, and Portugal. And as I mentioned to you, we have been part of the specifications, part of multiple forums since the very beginning out there. Now, these are the various software frameworks which we have if we talk about 5G. So starting from the RU, so we help customers create RUs. Those can be satellite RUs as well. On the G-Node B side, we provide the complete CUDU software. And then the SMO RIC, you have heard about SMO RIC since the morning. We offer those as well as XApps, RApps as well, edge compute, and the 5G core. So we cover all the assets required to actually build an end-to-end solution. Now, come to the second part. So why NTN and what people need to do when they think about NTN. So there are multiple factors to be considered when you are actually working on NTN solution. What are the various use case deployments that you are looking at? What are the modes, LEO, GEO, MEO? So there are multiple things that you take care of while you actually define your architecture. What kind of frequency bands you will be operating on? FR1, FR2, you have to take care of both. What kind of terminal connectivity you have to look into? Well, are you talking about terminals or you are talking about handsets, direct to device? And then multiple design considerations which you have to take care of while realizing an end-to-end 5G NTN solution. Well, so you have to look at the architecture design. What kind of satellite deployment models are you looking at? Are you looking at region-data architecture or a transparent architecture, a bent pipe architecture? Well, you would need to change your layer 1, layer 2, layer 3 software if you talk about our 5G RAN software. So intent here is to tell that as the telco providers or the equipment providers that you see out there, they have to modify all the layers in their specific gear to actually adhere to the 5G NTN technology or connectivity. And then, how do you design your solution? Do you look for a cloud-native architecture, or do you look at a bare metal architecture? A cloud-native architecture would be very much useful for a ground station environment. That may not be useful for a satellite payload environment where you have to go bare metal because you have to conserve energy out there. Well, we also see relevance of both SMO and RIC and XApps and RApps as people are designing these designing their solutions as of now for satellite connectivity. So I'll be talking about those as well. So, well, what I've tried to show here on the slide is that how ORAN architecture is applicable towards NTN. So what ORAN actually provides you? ORAN actually provides you a disaggregation between RU, CU, DU, core, SMO, RIC, XApps, RApps. So what this gives you is, this actually gives you flexibility to actually start with the bent pipe architecture. Have the CU, DU, core, everything on the ground station. You start with the bent pipe architecture, then move the CU, DU on the satellite, or maybe just the DU on the satellite. So this gives you that flexibility. And then why the RIC, SMO, and the XApps, RApps? Well, because when you are running these large number of satellites upstairs, you will have to manage them effectively. So that's why you need the SMO. And then why the RIC and the XApps? So that you can actually better manage spectrum, you can better manage algorithms, you can better manage schedulers, which actually runs on the satellite, so as to effectively give you those services that you're looking for. Well, here I've mentioned some of the benefits that you would find while running an ORAN-based architecture for NTN, but there can be many more. I think we've just started on how both telco providers and satellite providers can work together. I think it's a long journey, but I think we are looking forward to it, and this is gonna stay. I think from Capgemini perspective, ORAN, well, as an architecture, is best suited to actually for the NTN kind of environment. Thank you.
Brilliant. Thank you, Rajat. And last but not least, Ash.
It's coming up. Hi, everyone. Ashesh Mishra here. I work with Aalyria Technologies as their head of client solutions. I'm going to be talking a little bit today about complexities of orchestration and management when we add the non-terrestrial component to our general networks. So and I'm going to make a very broad generalization here. For the most part, terrestrial networks and non-terrestrial networks, satellite networks typically, they've existed for a long time. They've had services that cross the boundaries from one to the other, but they haven't really been deeply integrated. They've operated as two completely independent domains. With NTCS and all of the other work going on around NTN, now we are starting to envision networks that have assets that span the ground, sea, air, space, and beyond. I'm sure all of you are aware, all of these assets are very, very expensive. So it is in the best interest of the customers and of the operators that you manage all of these assets as a singular multi-domain network. Once you start doing that, you start facing certain very specific challenges. Most of those challenges come into play because of the dynamic nature of non-terrestrial nodes. These nodes tend to move relative to the Earth, sometimes across great distances. They have predictable motion sometimes, other times they have unpredictable motion, HAPS for instance. They may come in and out of availability zones at variable rates. So we have time dynamic instances, space dynamic, and in order to be able to stitch end-to-end services across all of these types of connectivity media, we now need to introduce dynamic intent, which is how a service behaves when you have these temporal nodes coming in and out. So what it really needs then is an orchestration and management solution that is aware of this temporospatial aspect, hence the temporospatial SDN. One method of addressing it, which is the method that we have adopted at Aalyria, is to create a digital twin and have it model all of these variances and all of this dynamic behavior ahead of time, using real-time and predicted weather, using live network telemetry, using a bunch of historical data that you've collected over the network, and then project over time what your end-to-end service should look like. This allows you, given the right amount of data and right circumstances, to proactively move your services around so that your highest priority services get delivered across any available asset in the network, no matter what. Barring an unforeseen event, this typically ends up working really well. The temporal spatial SDN solution at Aalyria, we call it space-time, tongue-in-cheek, but it has had about 10 years of near continuous development. For the most part at Google, as part of their initial effort for launching LEO constellations, then most famously as the controller for the Loon HAPS system, and then for urban meshes. In that time, it has logged a little over 3 million hours of lights out operation in real world environments, and it supports all orbits, all frequencies, including cislunar orbits and whatnot. Now, one of the key elements when we are talking about multi-orbit, multi-domain, multi-layered assets is we need to have methods to integrate and orchestrate across service providers, integrate and orchestrate across different domains of the same service provider, and find efficient solutions for your services regardless of the ownership of any particular node. And this requires open interfaces. This requires standards. That was one of the reasons why we gravitated towards NTCS relatively early. If we want to satisfy something that is along the lines of what IRIS is trying to do or US government is trying to do with HSA, by nature, it cannot happen without standardization. It also cannot happen without open interfaces. So last year, we open sourced our northbound and southbound interfaces. In the coming year, we are going to do the same with our East and West Federation interfaces. And at the same time, we are adopting what we believe are going to be the broadly accepted standards from outside of our realm. This has seen a fairly good degree of adoption across the industry over the past year of our existence. In that time, we've become fairly involved with the hybrid space architecture in USG. We're working on adopting RIC in our system with ESA. And then we've been selected for orchestration in Intelsat, Rivada, and Airbus Alto HAPS. So I invite you all to check out our interfaces and develop a guide and contribute, because unless we all build together and grow these integrations together, this is going to remain a dream. So thank you.
Fantastic. This is just going to be moved so that I can sit down, but we've heard quite a good narrative actually from Natalia at GSOA, who's actually sort of sitting there at the cusp with the ecosystem and their members on driving forward the right sort of standardization processes, lobbying for spectrum so it's fair and equitable. And Jerome, representing the satellite industry, but showing that there is a real confluence of development based on standards to drive forward terrestrial and non-terrestrial sort of solutions in the market, but it needs more work. Rajat explained what sort of work is required. I mean, it's not just software development and system integration. There's a real need for understanding of adoption of, ORAN-based technologies, which obviously are disaggregated in different parts of the stack. And then, very interesting, actually, when I read the slides, I wasn't even sure what you were talking about, but now I get it. But it's a very interesting concept that it's challenging but expensive when you're trying to build in these architectures together, but you need to deal with the dynamics of a multi-mode sort of solution architecture. So temporal-spatial, interoperable orchestration. Fantastic, based on standards. Let's get to some questions, if I may. So if, Natalia, I'd probably like to start with you, if you don't mind. you mentioned that there is a route towards 6G. I mean, there's still a lot of work to be done, but there is the real meeting of minds between 3GPP, GSOA, NGMN, and now maybe TIP. You know, how do we, what's your perspective on getting ecosystems to work together to drive forward viable, commercially led solutions in the market, while still moving and, you know, directing yourself towards having standards built in for 6G?
So thank you for the question, and I think indeed
It's not a small question, by the way.
It's not, it's not. But I think the complexity of the ecosystem right now makes us wonder questions that are a little bit more complicated too. But I think it's a good moment to wonder how are we doing it. As GSOA, I mean, we are not a standardization body, and we are not deciding. But we try to be very proactive in collaborating and in engaging and contributing as much as possible in representation of the industry. Of course, there's different levels. We have the 3GPP and NGMN and TIP, and there's initiatives. I think we are in a moment of action also. All these initiatives, probably, we can consider them looking at different different areas of the common goal. And I think the key word is going to be collaboration, how we share the information between all these groups so that we don't do things double, because I think no one has that time. But I think there's one key point that is going to be to do trial and error. I believe that we are an industry, satellite industry has always been a little bit more on the if you fail once, well, it's a failure, we don't do it, it's done. I think now we need to be a little bit more gentle with ourselves and try things. I mean, it may not work. Firstly, we know that there's even some projects that have failed in the last 5 years already. That doesn't mean that we should stop looking at it. It's going to get more complex. Competitivity is going to get also in the way. So we will have to look at different levels of the scheme, not just the pragmatic part, the legal part, the policy part. So it's going to be a tough time, but I think also a very exciting one. And from us, I think contributing and finding these forums in which we can discuss are key. And getting operators, getting terrestrial companies to try things and to see how could it work, I think that's going to be what will provide success, actually.
Okay, thank you very much. I appreciate that. And Jerome, wearing your Viasat Inmarsat hat on, and actually you're also a co-chair of this group. I mean, what's your view of 5G and Open RAN in general?
Okay. So, as it was discussed, satellite is kind of an industry where a lot of proprietary closed solutions have been developed over the last decades. And I think we should move away from that today. And I think the environment is really friendly to that migration. So basically, we invested some time in 5Gs to make sure that NTN would be recognized as a meaningful way to complement terrestrial networks. And we have invested a lot in contributing, in making sure Release 17 was released as it is to support actual GEO, LEO, MEO in FR1. And we also invest a lot of time for FR2 in Release 18, 19, along with enhancements for FR1. So 5G, especially for small devices, portable devices, professional IoT, I think the satellite industry has to be fully compliant from A to Z to NTN 3GPP. For FR2, as I mentioned earlier, it's a bit more nuanced because we also want each satellite provider to have room for differentiation. And even Viasat, we have our own radio access network, which are quite sophisticated, and we want to keep somehow that differentiation that makes us different. So that's where I think O-RAN can help us. There are a lot of interfaces that we could reuse. It's not because it's eventually our own RAN that we cannot implement the same interfaces as suggested by O-RAN. It helps really interoperability and potentially selecting different suppliers for different building blocks. The other thing I want to make sure to state is that for satellite, especially in the broadband, in K-band, there is an interest to have a converged core irrespective of the RAN provider. There is still a strong interest to allow for roaming between operators. That's a bit to the benefit of end customers, basically. So that's a bit where we are today.
Absolutely. Okay. Rajat, I see you nodding quite a bit. Do you want to add anything to that specifically?
No, I think what Jerome said is actually right. Well, from an 3GPP perspective, I think engine is the right space as of now. I think from an NTCS perspective, I think it was started maybe a bit earlier, but I think as of now, it's a very good space. Well, we as Capgemini obviously will have multiple roles to play in, well, as part of this ecosystem. Well, while we provide the software stacks at one end to actually help develop these solutions, we also act as a system integrator on the other side to actually integrate all of these various systems to come together. We equally work with the SATCOM players as well as the telco players, so we also act as a bridge there in between that. And I think there are multiple players who want to play multiple roles, so therefore disaggregation, interoperable networks is actually the main driver here, I would say.
Yeah, absolutely. I mean, and from a tip perspective, what I can see here is, when you stitch the various capabilities together, there can be viable end-to-end solutions. As far as I know, within the group, there are already use cases and requirements defined, which are very commercially led, and therefore requires a multiple set of vendors and providers and operators to come together. But showcasing that as viable options will maybe drive a spirit of more ecosystem development. I mean, Rajat, if Capgemini has quite a broad portfolio of sort of services there, is there something that you can see happening if you're looking at maritime use cases or NB-IoT or emergency relief or ultra-rural, whatever? I mean, can you see a light at the end of the tunnel when you bring different sort of services together there?
Okay, see, I can't name the customers here, but well, we, as of now, would be working with more than 10 customers as of now, specifically on the NTN side. Well, on the terminal side, on the satellite payloads, on the ground stations, as of now, and also working with the service providers because they also are intrigued on how these SATCOM services will get integrated with their current platforms. So we're also working with them as well. We're also working with a lot of vertical industries also who are actually also interested in how these services can be used. Automotive industry, for example, maritime industry. So we're also working with them to see how they can better use these services as part of the solution which they offer to their customers. So I think a lot is being done as of now. I think next 12 months you would see a lot of names out there who are already doing and who would be actually trialing, deploying solutions, and you would also find our name in there, working with them.
Of course. Jerome, you wanted that?
Just to illustrate that, the obvious use case around NB-IoT. So think about automotive. You have a sensor on board your car. A single sensor, same chipset, you can either roam into a terrestrial network or use a satellite connection. That gives you ubiquitous coverage, and that's really very appealing to MNOs, but also to the automotive industry. Same is happening for container tracking on board ships. They are at sea, you can use satellite. They are stored on harbors, then you can use terrestrial network. It's the convergence. This use case is particularly interesting, just to illustrate the power of the combination of the two worlds.
Very good. Leads nicely to Ash. Tell me a little bit more about how your platform can act as a sort of a viable glue that orchestrates those types of solutions.
Right. So there are two really distinct users of these kind of networks. One is the satellite operator themselves, who I'll talk about them in a little bit. And the other one is their end consumer. So for instance, one of the biggest consumers of satellite connectivity is government, right? So when we talk about the satellite operators, they have an inherent need to manage and control their network, which, for the most part, if you're a satellite operator that's been around for anything more than 10 years, has been a mergers and acquisitions area. Everyone has multiple constellations, sometimes in different orbits. So there's a need to have a broader degree of integration amongst your own constellation. And there are certain coordination challenges that come into play just because there are two satellites that have different operation centers, they have different capabilities. So how do you really create services that use the combined synergy of all of your assets? There are two parts to creating those services. One is the business part, right? What's the really differentiated use case for your network? But the other part is somewhat complex, boring, very involved process to build that infrastructure, which is just basically creating a solver for that network graph that takes into account the fact that there are going to be different nodes with different capabilities, with different spectrum, that you need to take an intent from your OSS and BSS system and convert it to commands for your underlying infrastructure. That's the part where we want to come in. We want to take away that repetitive task that you need to do for each subsequent satellite, and allow the operators to really focus on what differentiates them. How do you create those new interesting services for your customers? Onto the next level of users, using government as an example. We see with IRIS, we see with HSA, this need to create these public, private, multi-domain, multi-orbit, multi-constellation networks just for resiliency. The same need tends to happen for all of the satellite integrators. So if you're a Marlink or if you're RigNet, you're combining capacity from multiple different constellations and delivering a singular service to your end consumers. Telcos are going to start doing the same very soon. Especially if we start integrating 5G into the mix and go direct to handset, it's squarely in telco territory. So for those scenarios, you add into the overall complexity of managing an operator's network, and then now you need to coordinate across different operators. You need to coordinate frequency, you need to coordinate capacity, and you need to find efficiencies across all of these solutions. Now, as there are different viewpoints on Starlink's impact on the industry, it has been a disruptor, and all disruptors are good and bad. The good is there's innovation, there's this sense of urgency that has come into the industry. Personally, big fan of that ecosystem. But it has created price pressure. It has created a need for everyone to reduce their costs. And how do you reduce costs if your resource utilization is not as efficient as Starlink's completely integrated system? And that requires this ability to coordinate. And that's the second part that we are hoping to solve.
Oh, that's very good. Excellent. So there's competitive pressure in the market, and that's requiring a better way of optimizing the way the resources are. But Jerome, back to you. Where's the value? I mean, through this development path that's going on, the commercial value to the people in the audience. Sell it.
Well, what I said earlier, just coming back to the use case, which is very easy to get, which around NBA IoT, it gives to the RAN provider or to the core network provider a unique selling point, a differentiator. You can now sell that to either a satellite operator or to MNO and saying, I have a solution that can combine terrestrial and non-terrestrial network. Knowing that on the other side, the chipset makers are already on board and have committed to support NTN, at least NB-IoT, NTN, and 5G NR, NTN in FR1. So there are opportunities, and the fact that we are building up on that community here is powerful, and we can be seen as an alternative to closed ecosystem like Starlink, for example.
Of course, of course. Natalia, your thoughts on this as well?
Yeah, so I was just thinking, by listening also to my co-panelist, I think we are in a sweet moment for the ecosystem itself. And what is going to happen moving forward is also consumers at the end of the day do not care if it's one or the other, if it's an integration or if it's, I mean, I know that satellite is very trendy lately and we are in the mouth of everyone, whether they know who we are or not. But at the end of the day, what they want is it works. That's the only preoccupation in their minds. And I think what is our responsibility now also is to make that more accessible, so we understand what we are talking about, and me fairly, because I'm not very technical. But the common person and the politician and the one that's preparing all this policy for the future of the digital environment does not necessarily go into those nitty-gritties, but they need to understand the impact on it. They understand what automated car driving means because they drive a car. They understand probably what tracking and tracking of the goods and so on mean. And this is where I think we need to put also that effort on our narrative and what is the impact to society itself, what is understandable by the common person. And I think there is an effort that we, even though liked all the nitty-gritties, we need to put there so that regulation and the digital strategies from the different countries, because we also need to understand that this is not just going to be for a European environment or a developed environment. This needs to also benefit those countries that have different use cases to be developed. There's plenty of opportunities for IoT and for many other services that are in difficult to reach areas where satellite is key. And so I think we need to also think of those as a potential market, and indeed scalability and being able to reproduce, it's going to be a success to lower the cost, to make it easier for the consumer, and having now this moment of change in the mindset of the chip makers and on the terrestrial industry as a whole, because I've been here for a while. I'm happy when terrestrials start talking a lot about satellite for the first time in years. Mobile World Congress was a great environment to see how everyone is excited about this. And I think we should use that excitement from the satellite sector, from the terrestrial sector, from the consumer to have in their hands or in their IoT systems or in the cars. I mean, they know what satellite is. Let's use that opportunity and that excitement into our benefit.
That's really nicely put. Thank you, Natalia. And actually, it sort of feeds very nicely to a lot of I guess, the influencing that's happening within the industry. So if the chipset manufacturers are game, the satellite operators are game, there are providers out there that are ready, solutions can be showcased, certified, and then replicated, and that builds the narrative for better policy making. Many governments are there looking for diversification, right? And they're driving forward a confluencing of different industries and wanting to create solutions. So we should, as an industry, come together to drive that. I love that. I'm going to come to my final question. Basically, it's the same question to everyone. What is your call to action, or what is the essence of what you want to bring across to this audience here? Just a single statement. Jerome, go for it.
Well, as I said, during 2 years we have produced documentation, but we have not raised enough interest in the industry. So it's going to be my task, along with my colleague from SES and others, to recruit more companies to join that ecosystem and actually deliver some value. Because as Natalia said it very well, it's now the right time to do this because of that environment that is super friendly. So yeah, I'm going to be a bit more active and reach out to all the members of TIP, as well as the conventional RAN solution providers, and try to bring them on board.
That's a good, clear task for yourself. And work with TIP on that one for sure. Rajat?
Well, I would actually take what Ash mentioned, so price pressure. So I would say that actually is a boon to what NTCS is trying to do here, because, well, no, I think not many of them have billions of dollars like Starlink or Kuiper to actually invest in creating integrated solutions. So in those scenarios, what you need is standards. But things which are created based on standards, things which you can focus on either on terminal side or satellite payload side or ground station side, so that when you invest in what you are good at, and then rely on the ecosystem to actually bring the other pieces and have someone stitch all of them together to run a system.
Absolutely. I mean, I think even from a panel before, Open RAN is complex. If you take just terrestrial Open RAN, then you need the engine to be built in a multi-vendor stack so that the cars can be sold based upon integrators who can actually take it to market. So in some regards, you need the right sort of ecosystem to come to the table to support Jerome in that regard. Ash?
Just to extend the idea a little bit, the push towards standardization is important. It is absolutely one of the most important call to actions that we can have. A secondary call to action, however, is standardization itself is not going to be enough. You need to have openness in addition to the standards. You need to have implementations of those standards that people are willing to share, that others can come and write code towards, that others can come and make physical interfaces towards. So I'd say my add-on to Jerome's point is make the standards and also make the physical manifestations of those standards available, which goes back to the end of my presentation. There are a number of vendors in this ecosystem who are starting to open up their black boxes. So take a look at them, contribute, and expand the ecosystem.
Fantastic. Thank you very much. Natalia, any further thoughts?
And just to conclude also from my side, but I think we need to continue working together, but also I think it's a moment of action for everyone, and I don't know who everyone represents here in the audience, but I think it's indeed a great moment also to reach out to Jerome, but also reach out to GSOA for us to get to know better what you are doing, how can we collaborate, how can we work together. We represent the industry, so let's use these opportunities to continue moving forward.
Fantastic. Thank you very much. I think that's probably broad enough. We've got 2 or 3 minutes. Does anyone have any questions? Yeah, go for it.
So NTN, of course, as a user, I would love to have connectivity everywhere. But like 5G, it got rolled out, but operators are not getting much ROI out of giving 1 Gbps to my phone. Similarly, for NTN, what is the ROI? How do you see, there is, for the chipset providers, why would they want to be on the base station side of things? Because it's not economy of scales here. So what will be the driving factor that will motivate operators or chipset providers?
I think I mentioned that earlier, is that it depends on the use case, but for FR1, the IoT thing, which is easy to get, that's fairly clear. I mean, the chipset makers don't want or want to avoid proprietary solutions, proprietary waveforms, because implementing those on directly on chips, that's not economical. So maybe there are transient solutions that are going in that direction with Globalstar, etc. But if you talk with the chipset makers, they really want full compliance with the standard for, I'm talking about FR1, I'm not talking about FR2 again. So what's in it for them? It's basically developing devices that can be served anywhere in the world, whether by terrestrial network or by satellite systems. And that has a lot of value for them as chipset makers. And also the device makers are also interested by that. Now, talking about actual use case for handsets, for example, emergency message, yes. Voice, maybe. Broadband, if you have to put a 5 billion constellation, LEO constellation, to deliver some capacity to handhelds to try to replace the terrestrial networks, that's highly debatable. That's a commercial. So I think, yeah, we should not be blindsided by the story around standardization, but there are actually use cases which are very beneficial. Not all of them. We have to scrutinize the business value of that, but there are certainly use cases which seem quite straightforward.
Yeah, and just to add to it, this is perhaps the clearest growth path for that industry, I'd say. I'm with you that it's not completely obvious, but the terrestrial market, especially for fixed, is pretty saturated. You're replacing existing connections with more capable existing connections for the most part. With non-terrestrial connectivity, now there is this whole new ecosystem that you're going to be able to address. What satellites have typically connected in the past is not enough. I'm with you. I think they're making their bet on what can be connected in the future.
Yeah. Rajat?
And just to add, I think on the ROI, I think it actually brings a huge ROI even to the service providers. For example, I'm giving an example here. So when T-Mobile announced that partnership with Starlink, yes, T-Mobile is a number 3 network provider in the US. But actually, if with Starlink, if they're able to provide that with no cell holes and they are able to provide that ubiquitous service in the US region to its customers, it is actually saving those millions and billions of dollars it had to invest to actually make their network, but to actually compare it with Verizon or AT&T. So yes, they also see an ROI in actually working in this manner.
As in, it was better to do that approach than a last mile connectivity on terrestrial. Yeah, absolutely. And actually, if you add to this point, we didn't talk about RIC and XApps and RApps, which in itself are a manifestation of optimizing the network, but also actually developing a marketplace for developers, especially if there's open source not standardization, but open source approaches in terms of letting that go forward. Yeah, absolutely. I think another question. Yes, go for it.
Yeah, thanks very much. First of all, congratulations to the panelists. Excellent contributions. I'm Jerry Collins. I'm from Intelsat. So we are a member, competitor, and customer of the panelists. So we know you all very well. Thank you. I'm really interested in how O-RAN can contribute to something like Intelsat. I have to admit, I'm really intimidated by what I heard this morning. It's costing billions to develop that technology. It's costing billions to test that technology and all the various options that are possible. And I'm actually bamboozled by all the acronyms, even though I come from the cellular world. So what I'm really interested to understand is how, because the satellite industry, we invest so much in space. We're investing a lot more on ground, but we can't afford the numbers that were mentioned today. How can the satellite industry jump on to, like my colleague used the term piggyback, how can we piggyback onto O-RAN at the right point in time and avoid what seems to be an incredible cost, an incredible amount of resources that are going into it? How can we benefit in an efficient, costly way?
Two ways of looking at it again. One is, if we don't take the approach of adopting the standards that are being broadly developed and standards in which there are billions of dollars being invested, and we try and develop something on our own in satellite industry, a new version of DVB, can we afford that? That's certainly not going to be possible, especially, again, with the price pressure coming in. We have to be as efficient as we possibly can with our assets. The second part of it is getting the timing right with when these capabilities get adopted. I think one of the benefits that satellites have is just the lead time for the satellite is so long that even if we shorten it, it's going to be a couple of years before the first bird gets launched. I think the success of the ecosystem will come down to flexibility. If we can have multi-mission satellites, if we can have satellites that can be reconfigured dynamically, depending on the use case and how the technology on the terrestrial end is evolving, I think that's going to significantly reduce the cost, because then you can choose when you want to go and make that transition.
I think we just, for example, as Viasat, we just run an RFP, and we have many potential suppliers. Just by the nature of that, because we are relying on those 3GPP standard for that RFP, we attract a number of customers, and just the competition, the nature of the RFP should drive costs down. Hopefully, we'll see. But otherwise, I think taking the architectural principles of O-RAN is already quite beneficial. The way building blocks have been structured, the interfaces between building blocks, that has value if we can reuse them.
Yeah, and I think I tried to cover that in my presentation, that, well, it's a flexible architecture. You can actually start with the bent pipe architecture, have everything on the ground station, then see, well, which of these components you can move one by one to the satellite payload. So, well, it actually gives you an architecture through which you can innovate, you can bring more services. So when you are confident of actually moving from one architecture to the other, this actually has all the building blocks which allow you to do that.
Yeah, absolutely. There are points of piggybacking on it. It is complex. There's been a lot of investment in Open RAN, but actually, if you see now, the market has moved to a place where there are viable consortium-based solutions coming out. OREX, Vodafone has now started to create a charter around it. There was Symphony. So I think the market's moving in that direction, but I would agree with these gentlemen here that there actually are opportunity points of actually piggyback off things because of the flexible architecture, and the ecosystem is there to an extent. Okay, I think we're going to end today's session. We have one last question. Go for it.
Yeah. Hi, I am Miguel Gonzalez. I am from Capgemini, or an architect from Capgemini. I just want to have one question. In terms of compatibility of end-to-end solutions with Open RAN deployments, what are the advances being made in terms of improving network latency, given the strict requirements that 5G networks, in fact, have in this regard, and taking into account that we are talking about micro and milliseconds in this case? Thanks.
Okay, question around latency.
Okay, I didn't fully get the question, but latency is law of physics. So with a GEO satellite, round trip is 500 milliseconds for LEO. So we have to play with the law of physics. We cannot distort them. And I think a lot has been done by 3GPP. That was really 17 just to cope with Doppler, with long latency. And I think that's part of what has been well tackled by 3GPP, including, when you deal with the LEO, the moving cells, and all that has been well addressed. After that, it's just latency is latency. So you may have certain applications like gaming that will require very low latency, but most applications will work on long latency networks.
Yeah, Natalia, you would say something?
And I would say, just to add from more of a policy perspective, indeed, we spend a lot of our time explaining that the majority of applications do not have any requirements on latency, and that we, to a certain extent, should stop creating these artificial requirements for developing the future of connectivity of any country. Of course, there are applications that need it, and we should look at those and see if we can contribute or if it has to be done somehow differently. I think still we are an industry that is evolving and innovating very much, so we don't know what's going to happen next, but there's physics reasons. But indeed make this effort and make sure that the applications that we are talking about remain on the requirements that are relevant and necessary.
And in addition to the latency aspect, I would also urge you to think about availability. If you're not directly connected by a number of different diverse fiber and wireless connections, if you're running an application that is absolutely critical and requires absolutely low latency, there is no connectivity media out there that is going to satisfy your requirements. Even combination of them typically won't. So that further reduces the number of applications that are reasonably going to be connected and require low latency in the sub 10 millisecond range.
Yeah.
At that point, you really want to be hosting that capability at the edge.
No, it's probably very expensive capacity that you have to provide there. Okay, thank you very much, everyone. I really appreciate you joining us in this panel, and let's give a round of applause to our panelists.